You will now see an automatic test in action. After I put the KUDUwave on the patient's head and conditioned the patient to press a button in time, I will click the next button. Once I clicked on the next button, the automatic test will automatically start. I'm going to press the pause button to explain to you what you see on the screen. The KUDUwave tests on an audiogram. At the top, one will see frequencies, and on the vertical axis you will see dBs. So the KUDUwave will test from low frequencies, 125 Hz, up to 8 kHz. If you've got a high frequency audiometer, the KUDUwave can test up to 16 kHz. Normal hearing is typically in the top area, 0 dBs, and very loud sounds are right at the bottom here at 90 dBs. You were probably wondering why these bars pop up and down. These bars are the noise that the KUDUwave constantly monitor in real time as a test is happening. It means the microphone on the outside of the KUDUwave will monitor the noise and will represent it in bars at octave frequencies as here. If I keep quiet, you will see the bars will disappear. So you can see that these bars monitor the ambient noise. If you are testing a patient, you must make sure that these bars never go into the light blue area. The moment they go into the light blue area, you have to stop testing. You have to press pause, go and close the door, close a window, or ask the people outside in the waiting room to keep quiet, and then you can press the auto button again. The KUDUwave uses the Houston-Westlake method of testing. It means it will go softer, 10 dBs every time the patient presses a button, and will go louder, 5 dBs when the patient didn't press a button. For instance here, the patient pressed a button. Thumb up means the patient pressed a button. Software will automatically go softer with 10 dBs and present the tone again. Now the patient didn't press a button. Thumb down. It will go louder with 5 dBs, present the tone, and here again we see the patient didn't press a button. It will go louder with 5 dBs, present the tone, and there you can see the patient press the button. Software will automatically mark the threshold and go over to the next frequency. One can also do a manual test by clicking on these buttons. The up arrow means softer, the down arrow means louder, left means lower frequency, right means higher frequency, R means right ear, and you will see the audiogram changes to right side, red, or L for the left side. If you want to mark a threshold, click on this button here. Want to delete the threshold, you can click here. The shortcut buttons on the keyboard for these buttons, the up arrow is the up arrow of the keyboard, the down arrow is the down arrow of the keyboard, the left arrow of the keyboard, and the right arrow of the keyboard. To present a tone, you can press a shift button. Move to the right side, you press R. Move to the left side, you press L. If you want to mark a threshold, you press enter. If you see gray dots start appearing on the screen, it means the patient is pressing the button when no tone was presented. It means that the patient has got no clue what to do. You will have to press a pause button, explain to the patient what to do, and click the auto button again to start the automatic test. At 6 kHz, you can see there's an orange dot here and the orange dot at 25 dBs. That means the patient didn't press a button because he couldn't hear the sound. There's a green dot at 40 and a green dot at 30. Means the patient pressed a button when he heard the sound. At 8 kHz you see a typical malingerer profile. Orange means the patient didn't press a button. But how is it possible that he could hear the sound at 20 dBs but not at 30 dBs? So that green is not possible. You can also see a grey dot here. It means the patient pressed a button when he wasn't supposed to press a button. To the bottom, to the louder sounds, you can see the patient didn't hear the sound yet, 45 dBs, indicated by this orange dot. it's also not possible. So after you did an automatic test, you have to make sure that you don't have orange and green mixed up, because it might indicate that this patient is a malingerer. You also have to make sure that there are not too many grey dots on the audiogram before you can accept the quality of this audiogram. Once the software finished testing 500 Hz on the left side, it will automatically change over to the right side and start testing. I fast forwarded this video clip. Here you can see the right side was tested. Typically, in a normal hearing person, one will find a flat line at 10 dBs with up arrows. That means this patient could hear down to the soft sound of 10 dBs. The up arrow means we couldn't test softer than 10 dBs because it was officially decided not to test softer than 10 dBs. So typically one will find a blue and a red line at 10 dBs with up arrows. The moment you see that, you know this patient will have a PLH of 1.1. Once the automatic test is finished, the software will indicate to you that the software has finished testing automatically. I can click on the OK button and then on Save and Finish.